For decades, the story physics has been telling us about reality is, well, it's pretty strange, right? We've got quantum weirdness, invisible matter, endless multiverses. But what if that whole story is just wrong? Today, we're going to dig into a really radical idea called dynamic vacuum field theory. The claim that it can fix physics by starting from a completely different foundation. So let's see if it actually holds up. So, is modern physics really broken? I mean, on the surface, it seems incredibly successful. But as we're about to see, if you just scratch that surface a little bit, you find a field that's grappling with some major paradoxes and a lot of unproven ideas. It's gotten to the point where some are calling it a genuine crisis of understanding. So here's our game plan for this explainer. First, we're going to walk through what this crisis in physics actually looks like. Then, we'll introduce the proposed solution, dynamic vacuum field theory. We'll break down how it's supposed to work, see how it tackles some of the absolute biggest mysteries out there, and finally, we'll think about what it would all mean for our view of reality. All right, let's dive right in. The crisis. The sources we're looking at today describe modern physics as a field just full of what they call pathologies. And these are these nagging inconsistencies, these quick fixes that have been bolted on over the years, kind of like putting patches on a leaky ship. So what are we talking about here? Well, for starters, we've got dark matter and dark energy, which supposedly make up 95% of the entire universe, yet we have never, ever detected them. Then there's the vacuum energy problem, where our best theories are wrong by, get this, 120 orders of magnitude. That's a 1 with 120 zeros after it. And on top of that, you have a whole zoo of hypothetical particles, untestable ideas like multiverses, and the weird mysticism of quantum mechanics that never seems to go away. That is a lot of loose ends. With all these problems piling up, you really have to wonder, isn't there a simpler way? And that is exactly where dynamic vacuum field theory, or DVFT for short, comes into the picture. It proposes to sweep this whole mess clean with just one single elegant concept. Okay, so here's the core idea. DVFT says the vacuum isn't empty space at all. No, it's a physical dynamic medium, a single substance that is the literal foundation of all reality. Think of it like the water in an ocean. Everything we see, particles, forces, even space-time itself, is just a wave or a whirlpool in that ocean. I mean, it's a total reset of our starting assumption. So let's put these two views side by side, because the difference is pretty stark. On one side, you've got the standard model, which is this fragmented, cluttered zoo of particles and forces that needs you to invent extra stuff, like dark matter, to make it all work. And on the other side, DVFT proposes this single, unified field that logically generates everything, and it resolves the paradoxes without needing to invent anything new. It's really all about simplicity. Why have a dozen ingredients when just one could do the entire job? Okay, I know what you're thinking. A single field that creates everything. How on earth is that supposed to work? How can one thing create this entire complex universe we see all around us? Well, let's get into the mechanics.
According to the theory, it all comes down to this surprisingly simple-looking equation. This is what describes the vacuum field. Now, don't let the symbols scare you off, really. The key thing to know is that it has just two fundamental parts, and those two parts supposedly generate all of reality.
The first piece of that puzzle, represented by the Greek letter rho, basically describes the field's stiffness, or its amplitude. So think of it as the energy density of the vacuum, kind of like a universal elastic fabric. In this picture, mass isn't something a particle has. It's just a localized dip in the stiffness of the vacuum. And gravity? Gravity is just the curve in the fabric created by those dips, exactly like a bowling ball on a trampoline. And then there's the second part, represented by theta. This is the field's phase, or what you could call its coherence. And this acts like the rulebook for how things interact. So if stiffness is the fabric, coherence is the pattern that's woven right into it. It's what governs how waves ripple through the vacuum, and how particles, which are kind of like twists or knots in that fabric, behave and talk to each other. All right, so we've got our stiff, coherent fabric that makes up all of reality. Now comes the really cool part, the payoff. Let's see how this one simple idea starts knocking down some of the biggest puzzles in science, one by one. First up, the big one, dark matter. Physicists believe that about 85% of all the matter in the universe is completely invisible. They've been spending decades and billions of dollars searching for it and have found absolutely nothing. And DVFT's explanation is, well, it's almost insultingly simple. The reason we can't find a dark matter particle is because there isn't one. The extra gravity we see is just a large-scale effect of the vacuum's own structure. It's not a missing thing, it's a property of space itself. Next puzzle on the chopping block, dark energy. We can see that the expansion of the universe is speeding up, but nobody has a clue what's pushing everything apart. The standard idea is some mysterious force called dark energy.
The theory's answer? The vacuum itself is just relaxing. Its built-in energy density, its stiffness, is just naturally decreasing over billions of years. And this slow relaxation is what pushes space apart, making the expansion accelerate. And get this also elegantly solves that insane 120 orders of magnitude problem we talked about earlier, because in this model, tiny quantum jitters don't add to the overall energy of the universe.
So what about all that quantum weirdness? You know, the spooky, mystical stuff? Well, DVFT aims to get rid of it completely. So instead of a conscious observer collapsing a wave function, you just get a physical, nonlinear response in the vacuum field itself. Instead of spooky action at a distance, you have effects that are sent through the vacuum's coherence at the speed of light. It basically replaces fundamental randomness with deterministic behavior that just looks fuzzy when you zoom way in.
Okay, so let's pull back for a second. If, and it's a big if, but if this theory holds water, what would it all mean for us, for our understanding of reality itself? This brings us to the final and maybe the most profound part of our explainer.
You know, maybe one of the coolest things about this whole idea is that it doesn't just assume the laws of classical physics like inertia, it actually claims to derive them from the vacuum's own properties. So inertia, for example, is just the vacuum's stiffness resisting a change in motion. The laws of physics aren't just handed down from on high, they emerge logically from the very fabric of reality. And look, the philosophical payoff here is just, wow. It's huge. This theory paints a picture of a unified material reality with no mystical gaps. A deterministic cosmos where effects always follow causes. A universe where human beings are just these intricate, beautiful patterns in a single cosmic fabric. And where real law is found not in some unexplained mystery, but in the elegant simplicity of the logic underneath it all. But of course, that brings us right back down to Earth and to the biggest question of all. Is this a true picture of a unified reality? A theory that finally cleans up the mess of modern physics? Or is it all just another untestable dream? The sources do suggest there are ways to test it, but for now, it's a profound and provocative idea. It really asks us to question everything we think we know and to wonder, what if the deepest secrets of the universe have been hiding in plain sight all along, in the emptiness that's all around us?